Hello, Mr. Bainey here. This lesson is 2.1 integer exponents. The essential question for this lesson, how can you develop and use the properties of integer exponents? And our Common Core standard is up in the top right. Know and apply the properties of integer exponents to generate equivalent numerical expressions. Let's take a look at this table that's here in the beginning. We won't do everything here. The first thing I want you to look at is the 5 to the 4th power, and we have 5 to the 3rd power, 5 to the 2nd power, 5 to the 1st power, and so on. This is all just going to the right in that row. There's a trend there with what I'm reading you. And then we have 625, 125, 25, 5, and so on. So the first thing I want to point out is that we have different forms of these numbers. So I'm going to write it down here near on the right side. If you could do the same, please. 5 to the 4th. Well, it's an exponent form. That means 5 times 5 times 5 times 5. And when you multiply that many 5s together, you get the number 625. So here is some vocabulary. The 5 to the 4th power is called exponential form or exponential notation. Okay, the 5 is our base and the 4 is the exponent. The exponent tells us how many times that base is being multiplied. The next part, 5 times 5 times 5 times 5, is called expanded form. So if I tell you to expand out that exponential form, that's what it looks like. And then 625 is what we call standard form. So if I ask you to write something in standard form, just go ahead and multiply it all out and get a number. So looking at our table again, the standard form, 625, 125, 25, and 5, there is definitely a pattern here. So I'm just going to continue it. And 5 to the 0 is equal to 1. 5 to the negative 1 is 1 over 5. Don't worry too much about how I'm getting it. If you haven't found out yet, you can try to make the connection. But it's okay if you don't see it yet. Okay, I'm going to do more. The last one, 5 to the negative 2, is the same as 1 over 25. Okay, the next one, we got 4 to the 4th power, is that. 4 to the 3rd power, 64. 4 squared is 16. 4 to the 1st is 4. We have 4 to the 0, which is 1. 4 to the negative 1 is 1 over 4. 4 to the negative 2 is 1 over 16. Okay, start trying to make the connection if you can. I'll do one more. Now we're going to look at 3's. 3 to the 4th is 81. 3 to the 3rd is 27. 3 squared is 9. And so on. 3 to the 0 is a 1. 3 to the negative 1 is 1 over 3. And 3 to the negative 2, 1 over 9. Okay, so hopefully with this, you'll see some patterns, some things going on. Try to make sense of it. If not, we're definitely doing some more problems here. So keep following along. Let's go on and go on to the next page. Part A. Okay, the basic idea of exponents that you need to understand here so far is that if I have a whole bunch of the same number being multiplied together, you can rewrite it in exponential form. So that's the very first part here. We've got 3 times 3 times 3 times 3 times 3. And we can rewrite that, remember that's expanded form, we can rewrite it as 3 to the fifth power, or 3 to the 5. Okay, 5 is the exponent, 3 is the base. On the second part, now they've started grouping these, okay, which means now I can write exponential notation for that group and exponential notation for that group. In the first group, I have 4 of them, so it's 3 to the 4th power. The second group, I only have 1 of them. But total, all of it, all of these, I have 5 of them, okay? So what you need to think about is if I have if I have a group of 4 3s and a group of only 1 3, and I'm multiplying it together, okay, see that multiplication right there in the middle? What do I do with 4 and 1 to get 5? Let's look at the next one. I got 3 3s, then I have 2 3s. So 3 to the 3rd, 3 to the 2nd. But if you count up everything here, I've got 5 of them. 3 times 3 times 3 times 3 times 3 is the same as 3 to the 5th. Okay, so again, pay attention to, we've got 3 to the 3rd times 3 to the 2nd. What do I do with this 3 and this 2 in order to get a 5? If you know what that observation is, please go ahead and write it down here. Pause it if you have to. The next practice problem it gives us here, if you've noticed the pattern, is we're going to use that pattern to complete 5 to the 2nd times 5 to the 5th. If you're not sure what that pattern was, what I'm always going to tell you is expand it out. Yeah, right? 5 times 5 times 5 times 5 times 5 times 5 times 5. Write it all out if you have to. You should get 5 to the 7th power if you do this correctly, either using that pattern or writing it out in expanded notation. Okay. Part B, we now have 4 to the 5th power, 4 to the 3rd. If we expand it out, this is in fraction form, expanded 4 times 4 times 4 times 4 times 4, and the denominator is 4 times 4 times 4. Now what happens in the next step is the idea that 4 divided by 4 is equal to 1, right? Any number divided by itself is 1. So that's 1, where I crossed out with the red. 4 divided by 4 here is 1, and 4 divided by 4 is 1. So I'm left with that. When I have all those 1s that I'm multiplying by, the 1s no longer matter, right? Multiplying by 1 keeps it the same. So I'm left with 4 times 4, which can be rewritten as 4 squared for exponential notation. Okay. The connection here you need to make is, I've got some 4s, those are my bases. I ended up with the same base. My exponent was a 5 on top and a 3 on the bottom. What can I do with the 5 and the 3 to get my exponent of 2 in my solution? Okay, if you notice that pattern, please write it here and pause it. If you see the pattern, hopefully you can do this next problem. 6 to the 8th power divided by 6 to the 3rd power. You should get 6 to the 5th power. The next one, part C, 5 to the 3rd power, then to the 2nd power. Oh, so this one's a little bit different because now we've got one base, but it's raised to 2 exponents. So we're going to take the 5 to the 3rd, expand it. It's 5 times 5 times 5. So I didn't use the 2 yet. The 2 is still outside. So the 2 means I'm writing 2 of these. So here's one of them, and here's another one. There's 2 of them. Since we have 5 times 5 times 5 times 5 times 5 times 5, in expanded form, that becomes 5 to the 6th power. Going back to our original problem, our exponents were 3 and 2. So what do we do with 3 and 2 to get 6? If you see the pattern, write it down. And let's do this problem down below. 7 to the 2nd power to the 4th power should give us 7 to the 8th power. I want to skip a little bit here. Let's see if you can handle these problems on the bottom of the next page. The your turn, number 7, 8, and 9. Simplify each expression. I'd like for you to give it a try, so please pause it, try them, and then compare it to the solutions that I write down. Number 7. So 2 times 11 in parentheses to the 2nd power. So it's going to end up being 2 to the 2nd power times 11 to the 2nd power. Or you can write 22 to the 2nd power or you can write 484. That is the standard notation, the last one I wrote down. The others are exponential notation. I will certainly accept all those answers. So this is the nice thing about exponents, especially because the directions doesn't tell you. If it tells you write it in expanded form, write it in standard form, or whatever, then please do so. But here it doesn't say it. Number 8. 2 to the 2nd power to the 3rd power. So here's some ways to write it. 2 to the 6th power might be the most common way. If you did 2 times 2 times 2 times 2 times 2 times 2, you will get 64. That's our standard notation. If you kind of went halfway, you did 2 squared, which is 4. You could get 4 to the 3rd power. Those are all the same as each other. If you were to type them into a calculator, you would always get 64. And the last one, number 9. Again, a few different ways to do this. I'm going to show one way. 5 to the 3rd power is 5 times 5 times 5. And this -4 just means that it's going to be in the bottom of my fraction. So I'm going to write 4 of those 5s. And then also this one means it's going to be on the bottom. And then we know that 5 divided by 5 is 1. 5 divided by 5 is 1 again. 5 divided by 5 is 1. I end up with this on the bottom of my fraction. So I could write 1 over 5 to the 2nd power, or 1 over 25. Or, if you did a different method, you might also get this, 5 to the -2. Okay, all of those are all valid solutions for number 9. Okay, we're going to go ahead and stop the lesson there. Thank you for watching. Have a good day.